Hey everyone, I'm Marc Duiker, Developer Advocate at Diagrid, where we build products for developers to build and run distributed applications at scale. And today we're going to talk about exploring Dapr Actors in .NET. And let me start with sharing my screen. It's a very bright orange, so be careful for your eyes. All right, so how this is structured, I first go through some slides, a very brief Dapr introduction, then about the actor model in general. And then it's basically doing like lots of demos. So we start with some basic hello world type things with actors. And then at the end, I show you a bit of a larger example that uses Dapr Actors. And we will end with Conductor, one of our tools that can be used to visualize some actor information. All right, so let's get started. Of course, this is all about Dapr open source, and Dapr is ideal if you want to build distributed applications. For instance, like this, so kind of an e-commerce situation where you have like many different services that need to communicate with each other, and there are like different state stores involved, and you need to do some pop-up messaging. So Dapr is ideal here because Dapr takes care of a lot of the heavy lifting for you. So all of the communication that you need to do between services or communication across message brokers, the Dapr sidecar will take care of that for you. So, and that will also ensure that all of the communication will be resilient because Dapr will do a lot of retries for you. Observability is also built in because all of the communication goes through the Dapr sidecar. You can operate that very well. And the sidecar also makes sure that you can be very fine-grained in your security configuration to allow which services can communicate with each other, or which services can actually access some state store, or which services are allowed to publish on a message broker, and which services are allowed to subscribe on a message broker. So, like I mentioned, Dapr is like a runtime that has lots of built-in stuff. So that really is a time saver. And Dapr also speeds up microservice development by providing like an integrated tool set with all kinds of APIs that you will often use. And this is the complete set of APIs that Dapr offers at the moment. There's like 10 different APIs. It's really quite a broad tool set that you have. But today we're also only going to talk about actors. Another nice thing about Dapr is that with all of these APIs that are offered, the underlying resources, so the underlying infrastructure is decoupled. So even though you can use the state management API in your software, and the underlying state store can be configured to use whatever state store on either AWS or Azure or GCP or some open source project. And in the case in Actor specific, Actors is actually built on top of the state management APIs, and you can just plug in different kind of state stores that you would use for your actor model. So I'm going to do lots of things locally. So I'll be using like a local Redis container, but you can very easily swap that out for another state store. So Dapr is a runtime for building distributed apps across cloud and edge. Well, what does cloud and edge mean? Basically anywhere. It could be like a local machine, a virtual machine. I was just running it locally on my laptop. I also have like a local kind cluster that I'll be using, but you can really run it everywhere these days. Now, if you're not familiar with Dapr yet, Dapr is, you can use Dapr in a sidecar. So Dapr is not inside your application process, but it runs in a separate process in a sidecar. And from your application, you are communicating with this Dapr sidecar via the Dapr API. And you can do calls for instance, you want to invoke a method on another service, you can use this invoke endpoint. If you want to retrieve a key value pair, you can use this state endpoint. If you want to publish a message on a topic, you can use this publish endpoint. If you want to retrieve a secret, you can use the secrets API. And we'll see this a lot in this session. If you want to call a method on an actor, you use this actors endpoint. Now let's have a look at the actor model in general. Now, the actor model has been around for a very long time. So it was first described in this report called a universal modular actor formalism for artificial intelligence. So this was probably during the first wave of AI in 1973. The main authors were Carl Hewitt, Peter Bishop, and Richard Steiger. And they define it as a model of concurrent computation where the actor is the basic building block. There's a lot of documentation about it. I also include the link to this Wikipedia page. So definitely have a look there if you're interested in the history of this. And what they mentioned is the actor is like a unit of computation, and it has these three capabilities. It needs to be able to do like some processing, so some business logic. It needs to be able to store its state, and it needs to be able to communicate. And then most specifically with other actors. So these days you'll find more of a definition like this. An actor has like an identity, it has behavior, and it has state. What Carl Hewitt, one of the main authors of that article, also mentioned is if you have just one actor, yeah, you're not actually using actors, right? So then it's just probably a kind of a class and that's it. So you really are using the actor model if you use like hundreds or thousands or millions of actors. So then you are using the actor model. So when should you use the actor model? Well, if you have a problem space that involves many small and independent units of state and logic, and I'll give some examples in a bit, and or you need to handle concurrency and processing speed is important, right? So there are many things happening at the same time or almost at the same time, and you need to handle that very quickly and efficiently. Now, some examples include, for instance, gaming, because lots of online games deal with actors, simulations, which is also a sort of gaming, lots of trading systems. And maybe if you have attended the Dapr Day, virtual Dapr Day recently, there was a session about someone who created like a trading system based on Dapr Actors. Also transaction processing also needs to happen very, very fast. And IoT is also a very common example where you have like a digital twin of your physical device. Now, this is a question that we sometimes get. So when do you want to use actors, or when do you need to use like workflow? So in general, if processing needs to happen very quickly and you don't have like a lot of dependency on like a lot of third-party APIs, or you need to call out to different endpoints, and processing needs to be quick, then choose for actors. But if processing can take a long time and you need to involve lots of service invocations or lots of I/O, then choose for workflow. This is also described in a bit more detail in the Dapr documentation as well. So actors use like a turn-based access model. So what does it mean? So let's say we have like a set of customers and they all want to buy a ticket for the latest Taylor Swift concert. Let's say the first actor that actually gets to buy a ticket at this ticket actor, that request is accepted, but then the ticket actor will have a lock, and then other requests from other customers will actually be blocked. So no one else can actually communicate with this ticket actor now. So the customer A will process this transaction, right? The ticket actor will process the transaction, and once that is done, then the lock is freed, and then the other actor can process their request, and again the tickets actor will have a lock again because of this request that's been processing, and so on and so on. So this is very like a sequential, like turn-based access model, and that's also why it's very important that your actors are very efficient in the way they operate, right? Because it is sequential. Of course, you could scale out the number of different ticket actors that you have, so that's one way to scale, but it's always important that the things that an actor does are always very efficient and quick. Now let's move on to Dapr Actors in specific. So Dapr uses a virtual actor model implementation. And what does it mean? Well, it means that the actor lifetime is not tied to the in-memory representation. So which means that you don't have to explicitly create or destroy an actor. So as soon as you invoke a method on an actor, then the actor will be created for you, an instance will be created. And when an actor becomes idle, and then at a certain moment, the actor will be garbage collected. So this makes it very, very easy to use. A bit about the history of Dapr Actors. So as you can see, Dapr Actors was created in 2019. I think it was part of the initial API set of the first Dapr release. It was inspired by Service Fabric Reliable Actors because it was from the same makers, and that's from 2016. And that itself was inspired by Microsoft Orleans, which also came from Microsoft Research in 2014. So that's already 10 years ago now. And so all of these are like inspirations, because if you now compare, for instance, Dapr Actors with Orleans, they are quite different, especially in naming. I personally haven't used either Orleans or Service Fabric Reliable Actors, so don't ask me for like a comparison. But what they all have in common is that they are like virtual actor models, and they all have these features like timers and reminders, which I will cover pretty soon. The nice thing about Dapr Actors, which really sets it apart from other actor systems, is you can write actors in different languages. So at this moment, you can actually use 6 different languages. I'll be covering C#, but you can also write them in Java, JavaScript, Python, Go. And since Dapr version 1.13, which was released yesterday, you can even write Dapr Actors in Rust. So that's pretty cool. But what's even better is once you have written these actors, you can actually interact with them using any language that can use the Dapr APIs, any language that can use HTTP or gRPC. So that's really a powerful thing of Dapr Actors. I want to highlight some Dapr Actor users because so some people might think, okay, yeah, Dapr Actors, it sounds nice, but I've never used it. Who is using this really in production? Well, these are the companies that I know of who are using this in production. Schrader, they make all kinds of light armatures, and they're really involved in very big light projects. So for instance, if a tunnel needs to have a complete lighting system, they do that. Or if an entire building like universities need a light system, they implement that. Another one is Ignition Group. They deal with financial services and also, I think, banking systems and also some retail. They use actors. Zeiss, if you're into photography or for film, you probably know about the Zeiss lenses. So they need to use Dapr Actors as well. And one of the most recent one I've heard of is Derivco. A very big Dapr user, also at a very large scale. They make backends for online gaming. And I've put a link in here from a Medium post by Simon Hadley. That's one of their lead.NET developers who really writes in quite some detail and with some architecture diagrams, how they are using Dapr and how they are using this at scale. So Dapr Actors is really used quite a lot and then really in big volumes. All right, so let's say quickly have the diagram from how it actually works. So here is your application. In this case, we'll talk about .NET, but it could be any other language that Dapr Actors support. So your application contains some code that defines the actors. So your application will communicate with the Dapr runtime when you want to invoke one of these methods on an actor. And the Dapr runtime is then responsible for creating an instance of your actor, right? Because since they're virtual actors, you don't have to create an instance yourself. The Dapr runtime will take care of that for you. And if you want, you can use some state on some actors, and the actor instance will make sure that you can actually persist or retrieve some state. So if you look at that state, because Dapr Actors is built on, or actually uses the state management API, which supports key value pairs. So if you look at the keys that Dapr Actors are using, the key is like a combination of different factors. So it always begins with your application ID, and with your Dapr application ID. This is also very also the usual pattern when you use like the state management API. The key always starts with your app ID. But in case of actors, it also includes the actor type and then the actor ID, and then finally the key that you use regularly. So it's a combination of 4 things that is used as the key. And I'll also show you a bit later when I run the first demos. So something that a lot of virtual actor models implement, and also Dapr Actors, is timers and reminders. And those are very useful because you can actually schedule periodic work on itself. So I'll also show some examples of that, but there are 2 ways to do this. So timers are stateless, so they can actually you can have like a periodic execution of some logic, but as soon as the actor becomes idle and is like garbage collected, then it means it's gone. So there will be no more executions. And the other thing is like reminders, and those are stateful. And so even if the actor is not active anymore, they're actually like persisted. So even after actor deactivation, the actor will be rehydrated and it can execute the reminder again. So those are more powerful, also consume a bit more resources. Okay, then the important thing about how actors can communicate with each other and how they can find each other is that's called placement. This is also documented in the Dapr docs, but I do want to highlight this. So let's say we have 3 different applications here with 3 different kinds of actors, A, B, and C, and there will be some communication between A and C and C and B and so on. But how does the actor know where these different actors live, right? Because this is deployed on Kubernetes, they live on different nodes. So how does actor A knows where actor C lives, and how does C knows where B lives, and so on. So there is a thing called the placement service that is part of the Dapr platform. And as soon as your application gets deployed and it gets like a Dapr sidecar, the Dapr sidecar will check your application if there are any actors registered with that, and it will communicate this information with the placement service. So this will happen for all the applications. So the placement service is the place that knows all about which applications and which nodes, which instances contains which actor types. So there's a table, it's called the placement table, and this contains like a mapping of where all the actors live. So whenever some communication needs to be done, this placement service is used. Now, in order to be a bit more efficient, this placement table, this thing is actually cached at all of the Dapr sidecars, so they don't have to continuously call this Dapr placement service. So this is how they know. It's kind of an address book for actors. Right, let's have a look at the Dapr Actors API now. So this is the HTTP API. I'll be quite quick because the same things will reappear when I do the demo later. So if you want to invoke a method on an actor, you can do a post to the actor's endpoint. You have to specify the type of actor in the URL, then the actor ID, and then there's like a static field called method, and then you have the name of the method. So this is how you invoke the say hello world method on the myActorType instance A. Now, if you want to provide some arguments, then you provide like a JSON payload with it. In this case, Renee. If you want to get and set some state for the actor, you use the same actor's endpoint. You provide the type again, the instance, but then you end with state, and again you provide some kind of a payload that you want to save there. In this case, you specify an operation. So we do like an upsert now, and I mentioned before it's key value pair based, so you have to specify a request which contains like a key and a value. If you want to retrieve it, you use the same format, but then you end with the key, in this case, greeting. So if you want to set a reminder, you use the reminders endpoint, and reminders always have a name. So in this case, I use the name snooze. And then the payload is the due time. So that's actually a delay. So if we call this, it actually waits 10 minutes before it actually starts the reminder. And the reminder, that's like a bit of an interesting format, but the first part, the R3, means I'm going to repeat for 3 times. And then this is the period, and it means, okay, I'm going to run 30 seconds. So every 30 seconds, this reminder will run, but only for 3 executions. Okay, let's have a look at the .NET SDK now. And again, I'll be a bit quick because we're going to run this actually as some demos, so we'll see this again. If you define an actor, you first define an interface, and you inherit from iActor. It's like a base interface. So there you specify your methods. For the implementation, in this case, the hello world actor, you inherit from a base class called actor, and you implement your interface. In the constructor, you need to add the actor host and provide that to the base class, so everything is wired up correctly, and then just do your implementation as you would do normally. Now, if you want to use actors, you can do 2 ways. I only show the strongly typed one. You can also do a weakly typed one, but you use something called proxies. So you can use the built-in proxy factory, and then use the interface, create an actor proxy, and you need like 2 arguments there. The first one is an actor ID, and the second one is the class name of the actual implementation. So once you have the proxy, you can then invoke the methods that are available on that interface. So that works quite well. All right, now it's time for some first demos. I'm going to run everything locally, which means I have the Dapr CLI installed locally. And when you install the Dapr CLI locally, you get this placement service, which we now know what it does, the address book for actors. Redis is the default state store, so all of my actor state will also be in Redis. And we also have a container which has Zipkin. We won't have a look at it this time, but this contains all of your traces. So I'll have like 5 short demos. We start with simple hello world, then something with state, then an example of a timer, an example of reminder, and some actor-to-actor invocation. So let's go to VS Code. All right, so this is the samples I'm going to use. I'm actually going to run Dapr now and run this basic actor samples application. I'm going to start it up and then I'll show you what I'm running. All right. So what I refer to is this dapr.yaml file. So this contains my configuration of the apps, or in this case, just one app that I'm running. So this is my app, basic actor demos. I specify an application port and a Dapr HTTP port. I'm running, it's a .NET application. And I've got like indication where I want my app and Dapr logs to appear. In this case, it's all appearing here in my console. But I also have a reference to my resources path because since Dapr Actors requires a state store, I need a state store definition. So this is the state store file. So it's a component file, name state store, and we're using state.redis here. So what's important if you're using actors, you have to make sure that you add this attribute. So we have an actor state store and you have to set it to true. So that's really important. If you don't do that, you can't use the actor. So this is an important field to update your state store with. All right. So looking at my CS project file, I have a web application here. It's using .NET 8. And I'm using the Actors ASP.NET Core because it's a web project. And I'm also using the Dapr Actors one. And I'm using the latest version, 1.13. If you look at the program CS files, well, my startup code, what's important to realize is you need to register all of your actors. So here is my services collection. There's an extension method, add actors, and here you have some options, and here you need to use the actors.register actor method, and then that's a generic method, so you need to specify the type of your actors here. So if you don't do this, the Dapr runtime will have no idea that your application actually contains actors, so it cannot update the placement service either. So this is an important part that you need to do. Okay, let's go to the first example, and that's the Hello World actor. So here on top is the interface. So this is something from the Dapr Actors package, the iActor. I have my 2 methods here, say hello world and say hello, which accepts a parameter. And here's my implementation. So I'm inheriting from the base class actor, and I'm implementing my interface. This is the same example that you saw in the slides. So let's run this. And I'm using a VS Code extension called the REST client. And I have this HTTP file here, and that allows me to actually make a request straight from VS Code. And then whenever I make a request, I'll see the response in a window that will appear here. Make this a bit smaller. So what I'm going to do now is I'm going to do a GET request to my Dapr endpoint, to the actors endpoint. And this is my actor type, hello world actor. This is just a made up actor ID, user1. And I want to invoke a method, and the method is say hello world. Okay, so I'm now making the request, and what I get back is a response with hello world. All right, so it's working. And the other example is where I do the say hello and actually provide a payload, in this case Renee. So I'm making a request here, and then I get back hello Renee. All right, so that's the hello world example of Dapr Actors. That's great. Now let's move on to the stateful actor one. So this is the interface of the iStateful actor. There's 2 methods, one to set a greeting and one to get a greeting. And as you can probably tell, what's happening here is I use a key which will be used for the state store, and in the set greeting I'm using the built-in state manager. So this is in the actor base type, and the set async method provides the key and the value that I want to store. And for the get, as you can expect, again, the state manager and then the get state async, specify the type what I want to get out, and then I provide the key. So let's run this. So this is the first example. So I'm doing a post to this actors endpoint stateful actor, just made up a actor ID again, and I'm going to call this method set greeting, and this will be the payload, hello from stateful actor. So let's run this and get back a 200. Okay. So now let's do the get greeting to retrieve the value. Let's do it, and we get back hello from stateful actor. Cool. Now let's also show it in Redis, using another extension to actually visualize the Redis stuff here. Right. So we have an entry here in Redis now, and here you can see the key. So I have basic actor demos, stateful actor, user2, and greeting. You will see the same key here again as well. And here you see my data that is stored hello from stateful actor. So this is one way to work with state for actors, but I also mentioned there's like a state endpoint, right? So we actually don't have to create our own methods to involve state. We can also use this state endpoint. So let's try that as well. Again, I'm using the actors endpoint, the same actor type, also the same ID, but now I'm using this state endpoint, and this is the payload. So I want to do an operation, an obsert. I'm using the same key, greeting, but now the value is this. So do that, get back at 204, no content. So let's retrieve it also with the state endpoint. So this is the state endpoint, and I provide the key to retrieve it. And I get back at 200 OK, and this is the value. And also when we inspect this, we see indeed the value is also stored that way. The nice thing about this state endpoint is that you can actually combine multiple operations. So as you can see, you can do like 2 upserts of 2 different keys here. But what you can also do is you can also do like 1 upsert and 1 delete as well. So you can be like very, very flexible and also be like very efficient, right? Because with 1 request, you can update multiple keys. So that's pretty nice. So let me actually run this one. So I do an upsert for the greeting, but there's also now a date field as well. So if we look at it now, I need to do this. So now there are 2 keys, and there's one for the greeting and there's one for the date. Okay, let's move over to next example. That's the timer actor. So that's one that's the timer which is the, let's say, efficient one which does not get persisted. So the interface here is timer, like 2 methods. We create a timer and we reset a snooze count, because I'm also using the state management here. So this is the key for actually storing the number of times I hit the snooze, and there's also a name of the timer. So this is the timer method that you need to implement. So to register timer async. So that needs a name. In this case, it's snooze. It needs a method that will be executed when this timer is actually triggered. You can optionally provide a payload to this handler method, and then it's the due time again and the period. So in this case, we don't wait, and then it gets re-triggered every 5 seconds. So what happens in the snooze handler? We just do a console write line. We initialize a snooze count of 1. We then check the state manager if there is already another count, and if there is a count, we update that count value with 1, and then we store the updated count value. And then there's like a reset method to actually set back the snooze count to 0. Okay, so let's execute this one. The first one is the reset, but I haven't even called it yet, so it doesn't exist yet. So let's actually create a timer. So we're going to run this method here, create timer. There we go. And as you see here now at the bottom, we see that this is now triggered several times. So every 5 seconds, we get like a new message, wake up, and this will continue until we actually stop it, or we explicitly delete the timer. So that's what I'm going to do now. I'm going to delete the timer. So I'm going to use the delete HTTP verb for the snooze timer. Okay, so now it should stop. Okay, so let's move on to reminders. So those are the persistent ways of reoccurring work. In this case, the implementation is a bit different because you also need to inherit from a different interface called iremindable. So we have our actor. We only have a reset method now because the other method is coming from the implementation that we need to do for this iremindable. So again, this is like the same setup as before, but now we have to implement this method, the receive reminder async. So this comes from the iremindable interface. But a lot of this stuff is familiar, right? Because we still have to provide it a name. It is like a payload in bytes, and then there's a due time and a period again. But in this case, it's like a generic method, right? So you can call this with any reminder name. So that's why we are actually checking here, okay, is the reminder name that's coming in, is it the one that I expect? So is it the snooze one? And then the handling is exactly the same as the timer example. So let's run this. So the type is the reminder actor, and I'm going to run a reminder called snooze. And this is then the due time, so this is the delay, and then this is the period, but I mentioned earlier, so it will repeat for 3 times, and it will wait 3 seconds for each interval. So let's run this, and then you should see some stuff happening here again. Yeah, so snooze receive for reminder. There's the second one, and then it'll be the third one, but this should be the last one. Yeah, and now it stopped. All right, so this is great for scheduling periodic work on actors. Let's see, what is the next one here? I think that's the final example, the actor to actor. Where are we? Yes. Okay, so this is the final example, just to demonstrate how you can communicate from one actor to another one. So we have just one method here, call hello world, which accepts an actor ID that we are passing in. So this is the implementation. So what we're doing in this call hello world is we use the proxy factory to create a proxy of the hello world actor that we saw. That was the first example. So we specify the interface and we give it an actor ID. In this case, we use the ID that we get from the argument here, and we need to specify the actual concrete type of the actor. So once we have that, we have the proxy, and then we can invoke methods on that proxy. And in this case, we get back a result, so we return this result. Okay, so let's run this. So this is the actor to actor one. Actor to actor, so this has an ID of ID1, and we're going to invoke a method called hello world. And this is the ID of the hello world actor. So this is the ID of the hello world actor that we're going to call. Let's run this, and it should give us a result of the hello world actor. All right. Okay, so that's all of the basic examples. Let's briefly switch back to the slides. Oh, I see a raised hand. Okay, we can do a bit of a short QA first. Does the client need to have available to the actor definition interface in order to invoke them? In case I want to segregate the actor implementation with the client. No, I don't think so. No, you can definitely need use like a different client to communicate with your actors. That's totally fine. Yeah. So in this case, need I have it in this case, I don't really have a client. I'm using like HTTP calls, which is also a different client because I'm using VS Code as my client. But indeed, you can definitely have like one application or one service interacting with your actor service that lives in a separate application. And I see also Alice typing an answer. Thank you. All right. Okay, so the next example is a bit more, a bit bigger, also a bit weirder. That's like a funny example. So let's say we have like an evil corporation, and they want the employees to be more productive, and have decided to implement a system with smart alarm clocks that will wake up their employees at 7 a.m. But if the employees have not acknowledged the alarm within 3 snoozes, the alarm will send a message to headquarters, and it will lay off the employee. So hopefully this is like an incentive for the employees to get working very early. So in this case, let's say it's more of a simulation slash a gaming example. We have like a couple of different actors. So there's a simulation actor that actually sets up all of the things from headquarters, from regional offices, and alarm clocks and employees. So these are our 5 different actor types. And I will go through all of these types to see how they are all connected. As I mentioned before, this is all available on in our Diagrid Labs GitHub organization. So if this goes too fast, definitely have a look there, check out the code, run it yourself. Okay, so I will first run the sample and we'll then go through the code. So I need to go back here. All right. Oh, and by the way, I didn't explain it, but I'm also using like Code Tour for this guided tour through the code base. So you can see it here. These are all the steps that I'm going to go through. I also had it for the base or actor samples, but this really helps me have like a structured way through all of my samples. So yeah, so we will see this live. I'll get back to this a bit later. We need to move to another directory. We need to do a .NET build. Okay. Yeah, I got a lot of warnings. That's okay for now. Okay, and let's run this, and then I'll get back to the code. Okay, make this a bit bigger. Okay, this is good. Okay. So what I'm going to do now is, well, there was a front end involved, as you can see, and able to communicate from the backend with the front end. I'm setting up a WebSocket connection. So when I press this connect button, this will make sure that I will have a WebSocket connection with my backend later. So what I first do, it's called create actors, but it's more like initialize my whole simulation environment. So I'll do that, and I'll create like a system with 20 different alarm clocks. So that means like we have like 20 different employees. So here we are. And as soon as I hit this start time button, the time will start at 6 a.m. And then every second, time will increase with 10 minutes. And as soon as it's like 7 a.m., all the alarm clocks will then light up. So the alarm will sound. And then based on some randomization that I will show you later, some employees will hit the snooze button and some employees will actually acknowledge the alarm. And if the employees will snooze too many times, well, then the alarm clock will become red, and that means that they're fired. So let's hit the start. So we're starting at 6. Every second, 10 minutes increases. We see here the alarm time at 7. So all the ones in green, they are safe, but all the ones in blue are snoozing. And as you can see, there are like 5 employees fired because they snooze too much. All right, let's have a look at the code now. I'm actually stopping this. So again, I'm running this with Dapr multi-app run, and this is the dapr.yaml file that contains now 2 applications. I have an API, so that's my backend, which .NET, and I have like a front end, which is based on JavaScript and a processing library for the visual stuff. So that's why we run npm start for the front end. So if you briefly look at the front end part, so there are 3 folders here. Let's have a look at the front end first. So this is the main JavaScript file that drives most of the stuff. So the first button I click was the connect button, and this will execute this part, which will connect to a third-party service called Ably that I'm using as my provider for WebSockets for real time. I won't go into more detail there. You can also use something like Azure Web App Sub, for instance. Then the next one is this create actors a method. So that's the second button that I've clicked. And although you don't need to create actors, right? This does more like an initialization of all of the actors. So I'm calling some methods on the different actor types to make sure they have like an initial value. And we'll go back to that later. So what you see here, I'll be calling like a initialization endpoint on my backend with the number of employees or alarm clocks that I want to have. And then the final front-end function is the start time. So this will actually start the simulation. So that I will reach out to a start endpoint in my backend. All right, so that's everything for the front end. Again, if you want more information about processing or whatever, just have a look at the code yourself, or ping me later. So I have all of the interfaces in a separate project called EvoCorp Interfaces. That's of .NET 8 framework, and I'm using the Dapr Actors because you need the Actors base class. So just to quickly go through the interfaces here. So this is the main one called iSimulation, and that has the initialize actors method that takes an employee count, and it has the start time async. Then the next level is iHeadquarters, and that has a few more methods. It needs to know about the regional offices. In this sample, I just have one, but you can easily extend it to have more regional offices. So it needs to get them and set them. The headquarters also need to know about all of their employees, and it does that in a dictionary where you first specify which regional office ID and then the list of employees. So it needs to be able to get the employees. There's also a method to actually get the fired employees, and there's a method to fire a employee. All right, if you move on to the next one, it's the regional office one. Also, a few more methods. Here we have some data specific for a regional office. I think that's down here. So there's definitely like an ID, but there's also like a time zone ID to which headquarters it belongs, and what will be the sync time to set the initial time for all of our alarm clocks. Then there's a method to actually set the mapping of alarm clocks and employees, because at the regional office level, there they hand out the alarm clocks and they know which alarm clock belongs to which employee. There's a method to actually retrieve the employee ID based on an alarm clock ID. And we have a method to set the alarm clock time. And also a method to fire the employee, which in turn calls the headquarters, but we'll see that later. Then on the alarm clock itself, there is a method to set some alarm clock data and also to retrieve it. There's a method to snooze the alarm clock, to actually stop the timer, and to set the sync time. And then the final one is the iEmployee one. Just 4 methods. Again, it has some of its own data. Then there's a method to actually get the alarm response. So this, we'll see that later, involves some randomization if they are snoozing or are accepting the alarm, and just like a sort of a helper method to see if this employee is fired or not. All right, let's move on to the API project, because that contains all of the implementations. So it's the most interesting one. Again, it's a .NET 8 project, ASP.NET. And we see here that we are using the same packages before, ASP.NET Core for the actors and the regular actors one, and also a package for Ably that will handle my real-time communication. If you look at the program CS file here, and again, the actors one specific, we see that we register all of the actors here. But what you can also do is you provide some optional configuration for how the actor system is actually working. So for instance, I'm setting an actor scan interval here. And what that means is how often do the actors get scanned to see if actors need to be deactivated. So in this case, it scans every 30 seconds. I think this is also the default, but I just want to show that you can actually override some of the default behavior using these options. The other one I'm setting is the actor idle timeout. It says to 50 minutes. So for every 30 seconds, we do like a scan for the actors. And if some of the actors are like idle for more than 50 minutes, then there'll be garbage collected. I'm also configuring reentrancy config. We didn't really talk about that, but you could be in a situation that an actor can call itself, or you could have some kind of a circular dependency between actors. So an actor A can call actor B, and then actor B can call actor A again. So that is known as reentrancy, and by default, that is not allowed. So things can get locked. But if you enable reentrancy, you can set it to enabled, and you can even specify to what level you enable then the circular dependencies. I don't think I actually need it in this sample, but I do want to mention it explicitly because it can be quite an important feature. Okay, let's go to the first endpoint that is called to actually start everything up, to initialize everything. So that's the init endpoint, and here we are creating actually the first proxy. So we're using a proxy factory to create an actor proxy, the simulation one, and we call the init actor async method on that. So let's now do kind of a drill down into this simulator one. So we go now to the first actor, the simulation actor, to the init actor async method here. So the first thing what this actor is going to do is it's going to use the proxy factory to create the headquarters proxy. So that's happening here. We will also create the regional office and all the data before we actually saving that to the headquarters. So if you look at the add regional office method here, so what this will do is we'll create a proxy for the regional office. So that's happening here. It's setting some data that it needs to use. And then we need to create a mapping of all of the alarm clocks and employees. That's happening in a separate method here. So we know about the number of employees that we want to assign to this regional office. So there's this for loop. It will create employee proxies for all of the employees. It will also create an equal amount of alarm clock proxies for them. And then we add that to a mapping that is saved on this regional office actor level. For each of the alarm clocks, we also use a method to actually set the time. And we also need to set some initial employee data on the employee proxy. And so this is like the initialization of the entire simulation. Then the next one is the start endpoint of actually starting a simulation. So this will call the start time async on the simulation actor. So that's what's happening here. So let's do a drill down in that. So this will first create a proxy again of the headquarter proxy. Then this will loop over all of the regional office IDs that is retrieved from headquarters. And for each of the regional offices proxies that are retrieved in, we will set the alarm clock time async. So this ensures that the initial alarm clock time is set to 6 a.m. So if we look at the regional office actor and to this set alarm clock, so what's happening here? Again, we're getting some local data of our actor. The regional office, we set this sync time in UTC. So what we're doing here is we use time zone info to get a local time, because hopefully you're using a local time for your alarm clock. What we then get is we get the alarm clock employee mapping. And then for each of these alarm clock IDs in this mapping, we are creating an alarm clock proxy, and we are setting the time. And so this is a task, and then we wait until we looped over all of these alarm clock IDs, and then we set all these times using task when all to make sure we do this in as parallel as possible manner. Now let's have a look at the alarm clock actor. So this is the set time async. And what's happening here is we're using reminders here. Using actually, this actually you need, this is weird because we are using actually timers, but this is called unregistered reminder, but we're not using reminders. So this is like a naming issue. So we are setting the local time of the alarm clock. And send time update here, so where we communicate with the real-time servers to make sure our front end gets updated. And what we finally do is we register a timer with this timer name, the method that will handle the execution when this timer is triggered. No additional payload. It will wait for 1 second and then it will trigger every second. So if you look at the increment timer handle, what happens here is, well, we do some safekeeping to know, hey, is this alarm already acknowledged or not? Because if the alarm is already acknowledged, then the actor is actually done with work, so we don't need to do anything anymore. We get the time of the alarm clock, and then we increment that time, and then we set the time again. We do an update to our real-time system to make sure the front end is displayed with the new time. And then when we see that the incremented time is past the alarm time, then we go for the alarm handler. So let's see the alarm handler. So what we do here is we first check if the employee is actually still active. So because we don't want to alert any employees if they are already fired. The situation should not occur, but it's more like some kind of a safekeeping. We then get the employee response and execute it. So this gets back am I snoozing, or did I acknowledge the timer or the alarm? Then we get the actual snooze count, and we see if the snooze count is over the allowed snooze count. If that's the case, then we go to call the fire employee method. And also we do a real-time notification towards the front end. So let's go to this get employee response and execute. So the thing is, we're now in the alarm clock actor, and the alarm clock has no idea about the employee. So in order to find out the employee, we need to communicate with our regional office. So what we do is we create a regional office proxy, and then we do the get employee ID async, and we specify the ID of our alarm clock. And because the regional office has the mapping between the two. Then we have an employee ID, then we can create a proxy of the employee ID, and then we get their alarm response. And then based on the response, we either stop the timer, which means they have accepted the alarm, or they are snoozing. So the final part, this is the employee actor. This is where we get the response. As you can see, we're just using some randomization, just generate a number between 0 and 3. And if it's like 0, then we are actually acknowledging the alarm. But anything else, we are snoozing the alarm. So there's actually quite a high chance that the employee is actually snoozing, which makes it a bit more interesting for the demo. All right. So this is the snooze alarm then. So what happens here, we get the snooze count, we increment it, we save it, and again, we do like a real-time notification. And this is what happens if we are firing employee, so we received like too many snoozes. Then we do set the alarm to be acknowledged, right? Because we are stopping then the actor timer. We are getting the regional office proxy, and that will invoke the fire employee async method based on this alarm clock ID. And then if we go back to the one level up to our regional office actor, so this will get the employee ID based on the alarm clock ID. Again, we use like a proxy of the employee ID because we are setting this method to tell them they are fired. And what's also happening is we create a proxy for our headquarters, and also there we use the fire employee async. And that is this part, because at the headquarters level, they have like have this mapping of these employee IDs based on the regional office IDs. So we need to do some bookkeeping here to make sure that the employee ID is removed there. All right. So yeah, even though there are not a lot of actors here yet, there is still quite some code involved. Now let's actually run this on a local kind cluster and see what kind of metrics you can see in the conductor. Because out of the box, when you just use Dapr OSS, there's not a lot of stuff you can see when using Dapr. So let's actually go to a browser. And so I'm going to localhost, but now this is running in a kind cluster. So I'm going to connect it and going to do the same thing again. It's now for 15. It's fine. Let's create the actors and start the time. Okay, so this is going on, and then we'll switch to conductor to see what kind of information we can see about the sample. Right, so this is now finished. If we go now to Conductor, which is one of our products that can help you manage your Dapr clusters. So I have a actor demo cluster project here. And well, this is just like some main level insight what you can see. So you can see some information about your Dapr control plane, how long everything is up and running. In this case, I'm using one older Dapr version, 1.12.5. But what this shows is there is like an advisor. In this case, I'm not too interested in that because I'm running like a local development cluster in kind. But if you're running in production, and then this is actually quite useful to be able to know, are there any advisories regarding security, reliability, performance, and observability? What I can see is that I have like two applications. I've got this backend application and a front-end application. These issues detected, these are related to the advisories. In this case, I don't care too much about them now. I can see my pod state is healthy. That's good. I can also see that I have a state store component that I'm using. But the nice thing about actors is there's actually like an actors tab here. So there is some actor specific information. And here you can see the different actor types that my backend is using. And I can also see the number of active actor instances. And so you can see that there was just one instance of my simulation actor, regional office actor, and my headquarters actor, but there are like 15 instances of the alarm clocks and employees, which makes sense. If you open the actor ID, you can see the type when it was lost active, and also in which pod it runs. If you scroll down a bit, okay, so there's always a bit of a delay, of course, in having the metrics visible and seeing it here. Okay, here we go. Okay, so some of the metrics are coming in now. Not all of them, because eventually there should be like 15 alarm clock actors and also 15 employee actors. So this will actually increase a bit more. But here you can see like the invocation rate of all of your actors. In case you have errors, you'll see that as well. What's nice is that you can also see the timers. So if you have like big spikes in timers or something, you can actually see what's going on here. In case there are errors in your times, you can also see that. In case you have reminders, the same thing. But again, my demo didn't involve any reminders. So this is a nice way of getting a bit more information from your actors, especially if you're running this really at a large scale. Then it's really nice to see, okay, how my actor invocation is going. When are there like certain spikes? Well, what's happening if you do have like an error rate in my actors? Which actors are having errors? Because that can be quite tricky to find out. All right, let's switch back briefly to the slides. Again, I mentioned all of the demos I run today are in the Diagrid Labs org in Dapr Actor demos. So definitely have a look at that if you want to play around with it a bit more. thank you for sticking with me in this presentation. Feel free to claim this Dapr Community Supporter badge. It only requires a GitHub account, and then you can claim this badge. And if you want to know more about Conductor, feel free to scan this QR code that brings you to our Conductor product page. And with that, I'm done. Are there any questions?
Yeah. Yeah, there were a few questions that came in. It looks like Alice was able to answer them as they came in via the Q&A interaction. There was one more. Hold on just a second. I can find it. The question was, I'm going to start a new project where I can use the actor model, and should I use Dapr Actors? I think we know the answer to that.
The answer is it depends, right? So it depends mostly. Are you planning to just use .NET and are you just using actors and that's it, right? Or are you intending to create more distributed applications, and you also use like the state store features or the pop-up features that Dapr offers? So it really depends if you're only using .NET as a language, right? Because if you're only using .NET and only want actors, then you can choose one of the other actor implementations out there. But if you want more, either different languages, or you're also, maybe you don't know where you want to run it yet, right? So then it can also be very interesting to actually choose for Dapr, because you can run the state store just locally or in any of the major cloud providers. So it gives you a bit more flexibility if you choose for Dapr Actors. But it really depends on different languages or not, if you want to be flexible or not.
Yeah, that totally makes sense. We're at 5 past the hour, so we're fully out of time. Thank you so much, Marc, for hosting this webinar. Thank you to everyone who logged in and stuck with us through to the end. Keep an eye on your email to get that recording. And I think that's everything.
Great. Thanks, everyone.
Yeah, thank you. Have a good day.